Hello, trigonometry. Unfortunately, my son is coughing up a storm right now, and it is my turn to stay home with him. So, we are going to take a look at some limit properties today and how to apply them. It's pretty intuitive, I think. Actually getting the answer should be pretty easy. I'm just going to try to force you to write the syntax correctly. Okay, that's going to be the challenge. But getting the answer, I think, is going to be pretty easy. First, though, could you take a look at this example I've got here on the screen? And I'd like you to pause the video and work out, there we go, work out these limits here. Make sure you understand when limits don't exist, what they are from the left and the right, and then I'll come back and put the answers up to this. All right, but pause the video and try these out. Pause the video. Pause it. All right, here are the answers to that. Hopefully you tried them on your own there. So the first one does not exist. The left and the right do not equal each other. And so I do want you to be able to make a statement like this, okay? I want you to be able to correctly write out the left-hand limit and correctly write out the right-hand limit as we approach from the left, as we approach from the right. So this is approaching from the left. We are heading towards 3. Remember, that's the y value. And here we are approaching from the right, and that is going towards -2. Those are not the same. It does not match up. The limit does not exist. All right, that's a quick review of what we did yesterday. Let's take a look at some limit properties. All right, there are 1, 2, 3, 4, 5 properties here of limits I want you to take a look at. Don't freak out. They're pretty intuitive, and they're easy to do. So first, if you multiply the by a constant, let's say we have the limit, all right, of some function f of x, but we multiply it by a constant like 5. Doesn't have to be a 5, but I'll just use 5 as an example. You are allowed to take that 5 and essentially factor it out. All right, so that would be equal to 5 times the limit of f of x. You are allowed to factor constants out of a limit. It makes it easier sometimes. The sum and difference. So if we have two functions, let's say we have the limit, and inside the limit we have f of x plus g of x. And we are taking the limit of the whole thing. We're allowed to take that and break it up into two limits. All right, we'll take the limit of f plus the limit of g. That makes things easier. And that works for subtraction as well. Let me put a little minus under there. Plus or minus. That works for both addition and subtraction. The same thing works with multiplication. If I have the limit and inside I have two functions that are multiplying by each other, f of x times g of x, and we're finding the limit of the whole thing, we are allowed to break that up into two limits. The limit of f times the limit of g. It works for quotients as well, for division. If we have the limit, and we are taking a limit, but we have a function, a numerator, over a denominator, division. We are allowed to take the limit of the numerator first, divided by the limit of the denominator. And for exponents as well, if we are taking the limit of a function squared, all right, with that inside the limit, that is equal to the limit of f of x, do the limit first, and then square it. That's actually a pretty interesting one. That does not hold true for many other things. Like for sine, if you take sine of x squared, that is not the same as sine of x squared, right? Those are not the same. But they are the same for limits. If that square is on the inside, you are allowed to move it to the outside. Okay? Let me make sure we cross that out over there. It makes some things much, much easier. So what kind of problems am I going to ask you to do here? All right. Here are the popular types of limit questions where I'm going to force you to apply the property. So here we know two limits. We know the limit as x approaches 3 of some function f is equal to 6. All right, that's one limit we know. The other limit we know is for g of x. It's a different function, but as that function goes to 3, it's going to 16. So we know two limits, but I'm not telling you the equations. You just know this one point, essentially. And it might not even be a point. It could be an open hole. But we know the limit. So what is the limit as x approaches 3 of 6 times f of x? All right, 6 times f of x. Now, here's where the answer is pretty easy to get. Well, it's just going to be 6 times f. 6 times 6 is 36. It kind of works intuitively. Now, but that's not all I'd like you to be able to do. I would like you to be able to apply and show me that you are applying the property. The property is if we have a multiple in front of a function, you are allowed to bring that out. So this is 6 times the limit as x approaches 3 of f of x. Now we can just substitute. We know that this second part right here is just 6. So this becomes 6 times 6, which is 36. I know you can probably skip this step, but this is the step that I would like to see, okay? All right, number 2, the limit as x approaches 3 of g of x over 5. Well, that is just the limit as x approaches 3. I know we would think it's a fraction, but that is actually just 1/5 times g of x. Okay, think of it like that's a constant. The constant you can pull out. So that will be 1/5 times the limit of g of x. Well, what's the limit of g of x? 16. So that will be 16 over 5. All right, two more here. So the limit as x approaches 3 of f of x times g of x. So if we're multiplying these two, what do we get? Yes, it is just going to be 6 times 16. That is the answer, 6 times 16. You're multiplying the two functions, you get to multiply the two limits. I would like you to show me the property. This is equal to the limit as x approaches 3 of f of x times the limit as x approaches 3 of g of x. We are allowed to break that up into two limits, which then is 6 times 16. Well, whatever that is. I can't do that in my head. Come on now. 6 times 16 is 96. And the last one, we have the limit of a quotient here, f of x over g of x. So I'm allowed to break that up into two limits. The limit of the top over the limit of the bottom. All right, and I should probably put as x approaches 3, as x approaches 3. So now I can say, hey, the top one, I know that. It is 6. The bottom one, hey, I know that. That is 16. So our answer is 6 over 16, or what, 3/8? All right, those are some of the basic limit properties. I'm hoping they're pretty intuitive. I just would really like you to be able to show me this step right here, all right, where you apply the property. But hopefully the answer is pretty intuitive to get. All right, so I have, oh, well, we can skip that one, I suppose. Here is a couple of practice ones for you to try out. Yes, the answer's probably pretty easy to get, but see if you can apply the property to simplify it down before you get your answer. All right, so pause the video there, try these out together, and I should see you Friday with any luck. Have a good one.